Hello friends, welcome to my channel SAP Basis Expert.
So, work process is a very important core of this SAP basis area. So, this is the main design how SAP is working and how SAP is handling all these requests. All these requests, screen one, screen two are coming. It is handled by the work processes. Okay, so what is work processes? So, a process is essentially a program. Each process has a memory and access to system resource. Okay, so it's nothing but a program which handles you end users input and gives also the end users output. Okay, so take the input and process it and send it. It's required its own memory. Okay, and of course it's required ram, cpu, okay, etc. So that's what the access system resource. So how it works, so each process having a multi threads into it. Okay, so each thread acts as a component for each process that is executing at a one time. Each thread is capable of completing different tasks that its process requests. So thread is a single unit of execution, so one data comes to that process. So process is nothing but a application logic, okay, which process the input and gives the output. Okay, but to depend on that what input is coming, there are different threads which use by the process to handle the request or to process the request. Okay, so now now just keep in mind process is a nothing but is a bunch of application logic which is running behind or handling the request. Okay, but it's a different way. Okay, so here is a full picture. Okay, so here is a OS kernel. You can see the operating system is also having a kernel. So similar way this process is a part of the SAP basis kernel. Okay, and these are the binaries. Okay, it's a set of logic, it's a program set of program which take the inputs. Okay, and then it's handling the input. So some processes, like if it is a arithmetic calculation, then it's required the CPU. Okay, then it's used the CPU thread to calculate the plus minus multiplication steps, and then it's give it to the store it somewhere in memory, and then it's use it to somewhere, suppose we need some OS related activities to handle it for OS temporary memory we need it, or OS binaries we need to call it, then it's call it to the by that thread particular and then take it. Okay, and then whole that data processes is basically interacting with your OS kernel, CPU, your hardware, and then taking that input and giving to the your ABAP application logic to do this. So everything is running inside the process. Okay, it's most important to understand it's running everything inside the process. Okay, so these processes are divided into different category. Okay, what are the different categories? Like SAP online process, update process, NQ process, spool process, and background process. Okay, so online process are the processes which handle online users data. Okay, so whenever end user logging in inside and trying to enter some data or request some data, so that all requests are handled by this the online process, or it called the dialogue work process also. Okay, so it is handled by online work process or the dialogue work process. Okay, so update work process are used whenever the actions requested by the end user, it's required you to handle it by the database. So store into database, retrieve into database, so that's handled by the update process. Okay, so we also call v1 v2 process. Why v, what not, why not u? Because it's a German software where u they used to call v. Okay, so v1 and v2 we will going to learn what is the difference between v1 and v2, but this update work process only interacts with the database. So whenever if it is a request coming for the databases related, it's handled always by update work process. Then what online process do? Online process take the input, basic input, and then it is like only screen to display the login screen which I double click, right? It's not required any database update. Okay, it's just retrieving this. So the online process using that dialog work process is using that screen retrieving. Okay, updated after update also, if something is coming up, the details is again went to the dialog work process. The NQ work process work as a locking mechanism, which I explained in my last video. So that locking mechanism use and by the handle by the NQ work process. So it's very important, the NQ work process, because it's make sure that we have the consistency in the database. Okay, then the spool work process, it is handled for the printing purpose. Okay, the name itself is saying this, so it's used. So if there is any printing related stuff, the spool work process is handling this. So why these are different divided? Because they have the different threads. So for example, if you compare update and the spool, the update is having the threads which interact accordingly with the database utilities and getting the database getting interactions. Okay, but the spool, they need to interact with the hardware OS, the network, so that having the different kind of threads logic. Hmm. The background process is used though for the run to the background job. So what is a background job? So in SAP, we have facility to run some activities instead of manually. We can schedule it, okay, so that it will run automatically the time when you schedule it. Or some activities in the repetitive mode, you want to do it every day, okay, so you can create a job of it. Okay, so that job will run every day or every minute. You can give that schedule time, so it will run that automatically. Users don't have to sit and do that every time. So that kind of background jobs which is running for the longer period also can handle by the background work process. Okay, but then who will decide which activities, which work process will use on which time, when the end user is giving? So that's main is our one monitor is there, which we call SAP dispatcher. Okay, SAP dispatcher is nothing but the same work process. Okay, again, which is but having more authority. It will not do any kind of this work, but it has a kind of leader or monitor which monitors the request from the end user, and based on the request type, whether it is just a processing, then it's a dialog or process. If it is a update, then it's a database related, go to update. If it is a locking request required, then it goes to the NQ. Printing required, then go to the spool. So that SAP dispatcher is decide. Okay, okay, this request goes to the online, go to the update. Okay, and then it is handled by that particular process and get back to the dispatcher. So dispatcher works centrally as a it's like a manager who's asking the resources to work. Okay, and then the OS kernel is the same part. So SAP dispatcher is working as a leader for the SAP software. OS kernel is working as a leader for the OS which decides. So it's kind of OS is also one kind of software. Okay, so a component of SAP kernel called the dispatcher must manage process access to the OS kernel. So SAP dispatcher is having access to the OS kernel also. Okay, so how it work? Okay, so you can see when you install it, these applications on multiple servers. Okay, so each application is having one dispatcher, and there these different work processes. Okay, so these all work processes having one single file in SAP kernel. Okay, which called dis plus work. Okay, which depend on the configuration. If you say a dispatcher is always one. Okay, if you say the online update online or the dialog work process, I need the 10 dialog work process, then it will create a 10 times this process. Okay, if you say update, I need that only 3 update process, then it will create 3 more work processes at the OS level. Okay, so it's a uh, same file which is running multiple time. Okay, and the dispatcher is having one process only. It's not multiple, because one only handling is per server. But you can see the each server is having different dispatchers. Okay, which handling this. Here in database server, why it is showing? Because here scenario where the database and SAP application both on the same server. Sometimes we have in cluster method where we dialog instance we installed on the database also. So there, if we install SAP, if you only install database, there this will not have there. But database plus SAP, then you have this kind of processes running. Okay, OS processes running on the server. Okay, so you can see here some examples, the multiple users, they are requesting from all the side, four users. Okay, and then data is flowing. Then dispatcher read each and every block. So these are blue blocks, white block, this is a solid blue block, this is a lines block. So you can see these are different one flowing to each other, but it should not get mixed. This user requesting something, so ultimately this user should get the requested data, not this user data. Okay, so that's why it's complicated, it's running online everything. So dispatcher is handling all this mess. Okay, all this data, how to which, okay, this request required which work process to work, and if it is response coming, then send it back to the end user, etc. Okay, so these are the different work processes again which having different threads. Okay, try to understand, it's a different dialog work process, update work process, enqueue work process, spool work process, and background or the batch work process. Okay, uh, here I want to add it. A dialog work process are the same which I explained, but the update I mentioned V1 and V2. So V1 is immediate update in the database. So example of some airline ticket booking. Okay, where you are booking something, the ticket. Okay, then that place or that seat should get booked immediately when you save it. It should not be save it or save it, it's showing the user, okay, it's done, but it's not updated into the database. So that should not happen. Okay, it's immediately. Now you will say it's obvious, when we save it, it gets saved into database, then only it will save, otherwise it will give error. Okay, but in SAP this is not the provision. There is an additional one we call V2, which is called delayed updates. Okay, why delayed updates? Some work processes or some data which we are trying to save it, we can save it later, or it takes time to save in the database. So SAP, what it does, it's stored in some temporary tables initially, and inform user, okay, it saved it, and then that from temporary table to actual database, it save it later way. Okay, but then user get intimation that data has been saved. Okay, but when there is a critical data, we cannot take this risk, because later while saving into database there can be error occurred, and then it's not the actual saved happened. But in a critical situation, critical processes where it's not possible or not recommended, then it's use a V1 work process. So V1 is always updating immediately, V2 is updating delayed process. We will learn this later in detail way. Okay, so dispatcher in action, you can see the dispatcher how it is doing various types of messages. So this is a block, this suppose we'll take this white blocks only, it's coming to the dispatcher, and this application level, the request, it's request queues. Okay, so there is always a work process queues. So if it, suppose this first block is required dialog work process, okay, online work process, then it goes into the queue. If online work process is free, then the dispatcher send it to the next free one. Okay, but suppose same time this user is asking for the gray one for the online, but it is not free, it is using by this user, then it has to be in wait status. So it's called a queue, request queue. Once it is immediately free, dispatcher send this next request to this. So each request coming to the dispatcher, it's put it into the queue for each different work processes. Okay, so here are some example. The same way the Fred's user Fred Jones, which reading data XYZ, okay, on screen one here, this side, okay, and it's requested to the dispatcher, and then dispatcher trying to send that screen, but it has to be wait till the requested work process required. So maybe on this request it required the dialog work process, then database work process to just read the data, okay, also from the database, and then the screen one will have the logical processing to produce the screen. There is one more than dialog work process. So that all stuff dispatcher is handling, and the ultimate result is showing to the end user. Okay, so how the code works behind it, you can see, as I mentioned, these are the same diagram of the multiple departments SAP working as a centrally, and the screen which we are calling till now, we have SAP transactions we call. So what is SAP transactions? We have the each screen we have given a code, which code is for the end user, so they can call it easily. So they, suppose if you want to call the user screen where you create a user, okay, so you call a transaction su01. Okay, if you want to change the user details, you call su02. Okay, you just want to display the user, you call su03. Okay, so normally 0 su is a standard they given for the user creation. Okay, 01 is always normally 99% for create, 02 is for change, and 03 is for display. So these kind of different codes they have assigned, so users just execute that code and the screen will appear. Okay, it is so easy. Initially we will feel, okay, how we will going to remember this code, it's difficult, but later on it's easy. When you start working in the SAP, it's easily to remember it and memorize it. Also there is a provision that you can save that code on your screen, login screen, so you don't have to remember. Some end users, factory users, they can't remember it, they can just double click and it will get open. Okay, so these all SAP transactions are written in ABAP language. Okay, it's a four generation interpreter programming language which is created by CNCC. Okay, runtime environment. So dispatcher, whenever it's request coming from the user, dispatcher when using this, it's ABAP programming for these work processes are getting called. Okay, so if we go detail into the work process, each work process is having the task handler. Okay, so task handler is a thread which is handling the task, understanding the task, what is its purpose, what is it required, what we have to do, which memory or CPU or OS related stuff we need to access it. Okay, the DINPro processor is doing the dynamic processing of this one, and ABAP processor is used to process the logic or the code for the requirement from the end user. The memory part is storing the internal request. It's an internal memory we call, for each work process is occupied and for required some part of memory. Okay, for each work process to handle or to process this request. Okay, initially. So here you can see there now the two users accessing the same data xyz. Okay, so one is ideally actually asking for the read xyz, or another one is asking for the write xyz. Okay, so this enqueue process comes in a picture here. Okay, in a more way. So how it is reading data is happening. So screen one, when it's requested, I want to run a customer report for customer 17. Okay, then it give enter, then there are some another screen appearing. That screen 2, I only want to include data in my report that pertains to order that were filled within the last 2 months. So it will input the date field here. Okay, the 2 months, and then it will give the enter. Next screen appear, but only for product xyz. So that third filter he is giving it. Okay, so all these screens are going through the dispatcher one by one. Screen one come with this, dispatcher process it, request into the queues, work process it, send it back, and then screen two appear. Okay, then screen two it's giving this entry again, the second details of the date, it's processor giving the to the dispatcher, to the processor process it. Okay, work process is processing it, send it back to dispatcher, dispatcher send it back this third screen. The third screen, they enter this particular customer data. Okay, send it. So similar way each screen is getting interacted back and forth. Okay, but it is so lightweight that end user will not able to understand the delayed or the difference. If there is a delayed, there is some problem. Okay, so we'll go into more detail now. We have given different color for screen 1, screen 2, screen 3. Okay, so when transaction screen 1 requested, it goes to the dispatcher as I mentioned. Okay, then dispatcher put it into the queues. Okay, request queues. Okay, so there are some memories for SAP buffer we call. Okay, so that's a shared memory where some objects getting stored, where work processes details get stored, but work processes is having its own memory also. Okay, so dispatcher see, okay, there are three dialog work processes, this screen one required the dialog work process to get handled. Then these tools are busy. Okay, so you can see these are busy, they are processing some other end user request. Okay, this is free, then dispatcher send this work processor to work on this request. Okay, the orange one. Then this orange one stays in the memory. It will get processed by the DINPRO and ABAP 4 and the task handler together, and then it's processed, and whatever the screen or everything. So here it is just a screen, next screen is required. Here it is not interacting with the database. So it is ABAP 4 will generate the new screen, give it to the dispatcher, dispatcher give it back to the screen to the end user. Okay, here some more in details. If you go like the next one, this is the red one, screen 2. Okay, if it is coming in the queue, okay, if it is available, now the process request for the next screen is copied down. Okay, so here it is again copied into the another memory. Okay, the data retrieved for last screen is stored in the extended memory in area called the user context. Okay, so how these screens getting related, because here you can see multiple users requesting everything, right? So how this is getting, as I mentioned, this user should not get the screen requested by this user. Okay, each should have their own request. So that how handles it's the memory part. Okay, each request getting stored in work process memory, but the screen relation is stored in the extended memory. Okay, so that we call extended memory. Shared memory, here is a different part where the SAP buffers get stored. Okay, we will cover the memory part in details. It's a little complicated, but just understand it is different memory area handling the different memory to link, so that the each user getting their own screen requested here. Okay, and it should not get mixed up with their request and having handled smoothly. So that's what the SAP software is so consistent, and it's liked by all multiple organizations because it's consistent and smoothly working. It's so complicated inside, but it's a stable one. Okay, I will go to the update work process. So after third screen appear, then if suppose users want to do the save, okay, so simply if you save, it will go to the database work process, and database work process use database connectivity to store that all data which stored in the temporary memory or work process extended memory, right? So with this all three screen on the database, we call SAP logical unit of work, SAP LUW. Okay, so this is a whole one transaction. Okay, so this SAP LUW in normal scenario or best scenario, we see okay everything goes smooth and it gets saved, so it's saved in a database, so it's nothing happened. Okay, but uh, what if it is not get saved, or if it is something goes wrong, okay, or user decided to cancel it, then how it is goes, we'll see that, okay, in the next screen. But here you can see the update work process handle update request, the commit request or save request is handled by the update work process, three screen handled by the dialog or the online work process. Okay, here you can see how this v1 v2 I mentioned, right, the update. So if it is v2, so this screen related data, okay, whatever it is writing, it don't need to save it, right, it's need to save it later. Okay, that's what we call the delayed update. We are not saving that immediately, whatever input it is giving it. So that's stored into the VB log, so that we call v2 v2 update. Okay, delayed update. Okay, and the final one, when it's stored in a update data, it's stored in a v1 update. Okay, so it will read everything. Okay, whatever posting or the start dates, everything has been entered here, the data is stored in the VB log, and when the clicks on the v2 update, the update or process read this VB log data and it send it to the database finally. Okay, so summarize here VB log records how it happened. Screen one online dialogger process A, it's read that posting routing, it's read everything in that posting routing, the data use u1 update or screen one of three, it's getting stored in VB log because it's It's just an example why it's use U1 or V1 update, because it can be U2 or V2. It depend on the data. Decided by the automatically by dispatcher. Okay, dispatcher decide whether it should use the V1 work process or V2 work process or U1 U2 work process. Okay, so online this second it uses U2 and screen 2 of 3. Okay, third one same way it's using this data storing U2 and screen 3 of 3. So everything this is getting stored in the VB log. VB logs are nothing but a temporary tables, okay, set of tables. Here you can see the old screen of this SM13 transaction where this update, these updates are getting stored. Okay, this VB log tables, but it is not showing you tables, but it's showing the logical data. You can here see the U1 is not there, V1 and V2. Okay, so this is a kind of screen where you can check whatever the cancelled or update, whatever whenever update is happening in the system. V1 is executing, V2 executing, that execution, so live you can see that. So you can see here update is active. If it is not active, nothing will going to save in the database. End user will get the errors. Okay, we cannot, there is saving error. Okay, so this update is should be in active mode always. Okay, here we have the client and user in this report to select the data. Here we have type of records, explain as I explained it. Okay, here a date selection, so it's kind of a report to see this all v1 v2 updates in the systems, how it is happening. Okay, we will cover this later. Okay, so now as I explained, this is something goes smoothly. Okay, what happen if it is not go smoothly? Okay, while saving it's got some error. If it is a delayed update, right, in the v2 it's getting actual database update later, but while saving the database it's facing some error in actual in database. So what will happen, why, how this vb log will have the consistent? Okay, so that everything errors you can see it here. So that's what here we have this cancel one status. Okay, it's lies here. So whatever fields lies here, and then it's continue in a VB log. You can check later also what is filled, and you can reprocess it here. Okay, so it is like this in VB log in SM13. You can have these functions like where you can re-execute this VB log. Okay, we can talk to the actual end user, and then they get the messages when it's failed in their inbox later when they logged in later or in the same time, because it's a later update. Okay, so they can call the administrator or the functional guys, then they can check in SM13 and they can manually check if the data can be re-executed, need to be fixed, and then they will fix the problem whatever it is. Okay, and then they update it again, that's re-execution will done. Okay, so this is when the error during update phase. Here is some examples. Okay, so you can see the screens, the same screens we can take as an example where it's getting posted. Okay, so screen 1. Okay, and then it's done successfully in VB log, but while screen 2, okay, there is some breakout, some error, maybe system error. Okay, and then it's breakdown, then it will not doing the updates. Okay, it's doing rollback itself here, and the third screen it will get ignored in this case. Okay, so that's called the termination happen. Okay, so that was the v1 termination, immediate update. When we have the immediate, here you can see the both are a u1 update. Okay, v1 update. So u1 update, it's immediately in the database. How it's work in the v2 update? V2 update, everything gets stored in the vb log. Okay, so screen 1 stored in vb log, same way it is also u2. So you can see here it's a u2, so it's a v2 update. Okay, it's delayed update, so it's getting stored, though it is the same issue, but it will recognize later. So the third screen it will continue, it will not stop here like this, it will not getting ignored because it's not the immediate in the database, it will recognize later. So it will get stored in a vblog third screen also, but while actually saving it, it will get rollback from here everything. Okay, and it's lies in the sm13 where we have to recorrect the data. Okay, normally functional team they recorrect the data. So same way the NQ work process which I explained, it's used for the locking mechanism, right? If multiple users trying to access the same object, same table, okay, how the data consistency we need to be maintained. Okay, so everything that handled by this NQ work process. Okay, so the when user send the request for something, it's coming to the dialog work process, dispatcher assign dialog work process, then check, okay, it's required some objects to occur,
locked, or some tables need to be locked. So SAP creates their own objects locking mechanism, okay, with the combination of the SAP objects, program tables, etc., as well as the database tables. In that combination is create one object. That object it will use by NQ to identify if this object is already locked by other user. Then the same method, shared access, write access, exclusive access is there, and these all locking table stored in one lock table. Okay, so this lock table is always into the memory, it's not in the database, it's a temporary. So till the transactions get committed or the rollback by the end user, it lies in this lock table. You can check in this SM12 transactions. Okay, and this message service, one of the another work process message service which interact within the application servers. Okay, which normally we saw that, right, each work process applications and the dispatcher having, but message server is unique, NQ server is unique. Okay, so SAP in previous days central instance concept is there, we will study that later, but in central instance message server and NQ server, it's only one process, there are no multiple processes. Like we have the dialog multiple process, background multiple process, right, spool we can have multiple processes, then we have work processes multiple way. But message server dispatchers also can be multiple, but on each application server. But overall message and NQ server, they are only one, they are part of the ABAP central service. Okay, so these are central service, they work centrally to coordinating between application servers and all locking mechanism, because locking mechanism has to be unique, which handles for all applications, all work processes together. Okay, so within message servers and NQ, they decide the lock table entry here. So suppose one user is trying to access one table, for example, if it is trying to access XYZ user data, and then another also wants to try to access the XYZ, first one will get in read write mode, but the second one will get in a display mode, and it try to read write it again, it will say no, it's logged by so and so user, you will get that message. So here is the SM12 kind of entries you can see in the system, which shows you the data. Here you can see this client number 10 and ABAP 03 user, he logged this table, TADR table, and this is a lock argument. Lock argument is a normally combinations which SAP use with the objects, and this is dynamic one. Okay, but it's locked, so somebody other ABAP 05, when it's trying to access the TADR, it will get the display access, it will not get some the write access here. Okay, so SM12 you have the same select screen where you can select the data and check whatever the lock entries are there. So here are some examples like client, user, time. It is shared lock. Okay, here if it is shared lock, it's a display for both, and this is a tables and this is a lock argument. Okay. So here is some illustration how it works. So suppose work process, there are two work process, they are waiting, and this is a lock table. Okay, so they are trying to do the lock request object 001. It's going to be wait lock because it's already in the lock object. Okay, and we should not delete it immediately. Okay, because that will cause the inconsistency otherwise. Okay, so normally we monitor this basis administrator, they monitor it daily basis, and if it is a all entries, they will have to check whether it's corresponding jobs or users still running this, that's where the lock objects is there. If something happened, network error or some user abruptly disconnected, then some lock objects remain here. Okay, then we have to clean it manually, but it is has to be done carefully. Okay, then if you move to the background work process, it's used for the running multiple activities in a scheduled way. Okay, in a background, as I explained earlier also, we can automate it, kind of some stuff that user need to do it daily basis, instead of doing it manually, they can do it in a background job. Okay, so there is SM37 transaction where you can give the job class, you can define, you can monitor it. Okay, you can schedule it. Okay, SM36 is where you have SAP standard jobs, which runs as a housekeeping kind of jobs, which you run it, and that all jobs run it a background job. Okay, so what is the difference between online and background? More one is online job or online work processes, dialog work processes, they have limitation to run for certain period we can set. So default it is a 10 minutes. Okay, if something is running more than 10 minutes, it automatically get killed by the system. But if it is a background work process, you can run it as long as you require. It can be run for a days, it can be run for a month. Okay, but not suggested for such long period. But normally that's what, if it is a long running process you want to run it, you can run it in the background and you can go your shut down your laptop and go to home. Okay, and but next day you can come and user can check, okay, whether background job that completed, and they can check the result in a spool. Okay, so that is the spool. Next work process where it's creating the report, or it can be used for the printing purpose.
Okay, so let's have some demo how the work processes are looks like in SAP software. Okay, so I'm logging here to SAP GUI with DDIC user. Okay, so here you can see the work processes in two transactions. One is SM50. Okay, retrieves. So here you can see there are different work processes like dialog, update, background, spool, update. So we have total dialog 6 work processes. Okay, out of that 5 are free because one is used by my screen. So you can see this is start with 0 always, and this dialog work process is used. Okay, it's running. So here we have 6 dialog work process. Okay, so 0, 1, 2, 3, 4, 5. So this counts total 6 dialog work processes. So here you can see the type dialog. Then you have update work process. We have only one update work process, so that is next one. Then we have 3 background work process, so we will have here BTC, background work process. So you can see 3 background work processes are there. Then one spool work process, and then update 2. So this is v2 and this is v1. Okay, so this is just UBD is v1 update. Okay, and this is the v2 update. So this is looks like this, and whatever processes user is requesting, dispatcher sending to this one of the work process to process it. Because now you can see this screen is also a request. Okay, and which is handled by this dialog work process. It is running mode, it is not in waiting. Waiting means it is waiting to get the command from the dispatcher. Okay, and running means it is running some process. Okay, so if it is running, then it is doing something. You can see it keeps on changing. If I keeps on refreshing, maybe after some time, if I try to do again refresh, it will go to the another work process. Okay, it was on the 0 initially. If I do something else and then come back because it is doing some more work. Okay, fine, it's not changing, but it's changing when there are lot of work processes are there. Or maybe I can go back here and 3, and I can do come again in SM50. So it's on the 5th now. Okay, so this is the work process how it looks like in XAB actually. Okay, so this is one for the SM50 for local application server. If there are multiple application servers, we can check in SM66. Now it's shifted to the 4th application server. No, it's still on 5th. Now it's 3rd, then 5th again. Okay, so it keeps on changing when the new request is sending to the system. Okay, so it is a look likes like this on the SAP, and I will show you how it looks like in the uh, OS level. Okay, so you can see this is the one single file. Okay, the same file DW. Okay, it's a kernel where the kernel's files are there. Okay, so if I log into this one, where we have the kernel, and this is the file in the kernel. This is the file. Okay, so this is the one which has the binary. It's a binary file. Okay, which has all the codes of the dispatcher. Okay, and this is a this getting called multiple times. So this file is getting called and create one work process here. Okay, it calling second time again, a second instance is a second work process. Okay, so these counts are depend on this. Okay, so you can see here number of work process dialog 6, right? So it will create 6 work process here. How you map it? So this is the process ID at OS level. So 34875. Okay, so you can see here 34875 must be somewhere. Okay, maybe this is not the work process. We can check 34896. Maybe this is a dispatcher, because dispatcher is using also again the same one. You can see the 34875 is parent for everyone. Okay, so this is the main process. Okay, with dispatcher work process, and then this called the other work process 34896. So you can see the 34896, the zero address, 34897 is the second one, so on. Okay, so this same work process, so there is a same code behind it, only it's flag it as a dialog, update, background, and also, so there is a chance that, or there is a mechanism which we can change dialog to update, sorry, background work process and background to dialog dynamically. Okay, so we will check that in later another sessions in other transactions detail. But now you have the feel, right? So it's all the work process which are same, but they work differently, they behave differently, how you flagged it or how you named it, and then dispatcher assign the work accordingly to their uh, uh, purpose. Okay, so what we learned today, so we learned today what is work process. Okay, and what are the types of the work process. Okay, so to just remember, you have to remember this BVEBMGS. Okay, so this is in old age, as SAP software, they used to have the instance with this name. In fact, okay, so D for dialog. Okay, V for update. Okay, so update one, V1 or V2. Okay, so V2 is a delay update. Then E for NQ. Okay, V for background. Okay, me M for message server. Okay, message server is always unique. Okay, and what is another unique one is NQ. Other work process you can do, you can give in a profile how much you want, how many uh, work processes you require, you can define that, and you can have multiple one, but NQ and message server is always one in per instance. Okay, then here we have some G which we not discuss, so it's a gateway work process. So gateway work process normally uh, used to communicate outside the SAP world. Okay, to communicate from one SAP system to another SAP systems, or SAP system to non-SAP system. So it's communicating request, accepting or sending via the gateway work process outside the this instance. Okay, and then S1 is the spool work process, which used for the printing as well as storing the background job data. Okay, so we are finishing here.